Control systems is the subject that mainly deals with the analysis of a given system. This subject is common to electrical and electronics engineering as well as electronics and communication engineering students. This is basically a linear control systems. Linear means a system is said to be linear if it obeys law of superposition and homogeneity. Such control systems exist in domestic appliances, almost all transport systems, electric trains, aircraft, robotics, etc. In this subject, we mainly deals with analysis. What is meant by analysis? Analysis is nothing but study the characteristics of an existing system. What is its purpose? Purpose is, if you know the characteristics or the behavior of an existing system, we can design a better system. That is the meaning of analysis or design by analysis. The textbooks that are prescribed for these control systems are Control Systems Engineering by Nagarath and Gopal, Control Systems Engineering by Ogata, and Automatic Control Systems by B.C. Coe. First two books are with the title by Control Systems. This is Control Systems Engineering. These three books are the Bibles of control systems, and later on many books have been developed. The main intention of this subject taking is we should know the basics and fundamentals of the subject that should help to analyze the given system. Now, coming to the definition of control system, a system is excited by certain input. It gives some output. That output may be proper but may not be desired. A system is excited by certain input, it gives certain output. If I add a term control to this system, excited by input, it also produces output. This output is desired output. For example, fan. Fan is a control system. Fan without blades is not a system because no airflow. Fan without blades is not a system, and fan with blades yes, I can say it is a system, because system is nothing but collection of certain components, arrangement of some components connected in some fashion to perform certain objective. Fan with blades, of course, without regulator. Fan without regulator is also a system, but I cannot call it as a control system because the output of the fan is speed. That speed cannot be controlled without regulator. So, I cannot say that it is control system, but it is a system. Now, fan with regulator is a control system. Fan with a regulator is a control system because that speed can be regulated. You can get different speeds by changing the position of the regulator. Now, the control system can be further classified into two systems, that is open loop control system and closed loop control system. Control systems is subdivided into open loop control system, closed loop control system. The examples of open loop control system are iron box, washing machine, a fan, microwave oven, etc. The control system mainly consists of a controller, then plant or process that is to be controlled, and then output is obtained for some input. In this example of iron box, there is a knob that can change the position of position like telecotton, polyester, cotton, etc. So, there will be certain amount of heat that will be transferred from iron box plank to the fabric. So, during this process, the knob helps the required amount of heat to the plank and then it gives to the fabric. It is an open loop control system because that output here is a heat and there is no measurement of heat. And take the example of fan. So, there is a regulator in the fan. You can adjust the regulator, to have some desired speed. So, fan will run at the desired speed. Assume that regulator have 3 or 4 positions and correspondingly that fan runs at different speeds. Assume that the rated speed of the fan is 750 RPM revolutions per minute and fan starts running at this speed. But it is not sure that it is running at 750 RPM or not. There may be a variation in the speed, it may be 740, sometimes it may be 760. Even in the case of iron box, as I mentioned, doing an iron in Hyderabad is different from doing iron at Himachal Pradesh. The reason behind this is that there is an environmental effect on the appliances. Environment means the temperature, humidity, etc. So, there are some external parameters that may affect the output, but still almost all domestic appliances are open loop control systems. We do not require the speed of the fan should be 750 RPM only for certain position of the regulator. It does not matter even if it deviates the speed from low value or some high value. That is why almost all domestic appliances, fan, washing machine, iron box, microwave oven, etc. are open loop control system. There is no check on the parameter, output parameter in open loop control systems. That is why the open loop control systems are very simple. Open loop control systems are very simple, economical and generally stable. The only disadvantage of open loop control system is accuracy. When you are expected to have accurate output, then open loop control systems are cannot perform that operation. So, we need to go to the closed loop control system. As a matter of fact, traffic signals also are open loop control system, in the sense that these traffic signals operate based on the timer, not based on traffic density. So, whether traffic is there or not there, whether traffic is heavy or low, that signals will not bother. They just operate based on the timer. That is why it is open loop control system. No doubt control is involved, but it is not a closed loop, because purpose of closed loop control system is to expect accuracy and some purpose. So, all these open loop control systems with sensor, all these control systems with sensor will become a closed loop control system. That means before input there will be some element called error detector, and this output is being sensed. This output is being sensed by a sensor called feedback element, and that output is taken to the input and then compared, and there will be an error, and then action of this controller now depends not only on desired but also the actual output. So, the difference in the actual and desired will be an error, and this controller action depends on that error, so that you can expect the desired output. A very simple example I can take: an automobile system. Suppose we are driving a car, then if there is no speedometer, then I can say that it is an open loop control system. So, car will have a controller, an accelerator, and then plant is nothing but this is accelerator, controller, and car is treated as a plant. So, suppose you are expected to go with the speed of 60 kilometers per hour, that is your desired. So, still you can go with open loop control system, but it is not sure that whether you are going with 60 kilometers per hour or not. It may be 50, it may be 70, but system can still work. But in the closed loop control system, if I have a speedometer to measure the speed of the car, say it is running with 50 kilometers per hour, then my wish that is 60 kilometers per hour. So, what is the error? That error is difference between this input and actual output, that is 10 kilometers per hour. So, I can press the accelerator to make this error minimum, that is 0, so that output car must go with 60 kilometers per hour. Once it is achieved, then action of the control system stops. Means you need not further press the accelerator because you have already reached 60 kilometers per hour, that is indicated by speedometer. So, a car with speedometer is a closed loop control system. Without speedometer, it is a open loop control system. This way, we can give n number of examples for open loop and closed loop control system. So, control system, closed loop, if you take a plant or process, this may be influenced by external parameter variations like humidity, temperature, etc. It may be an internal reason or external reason, but this plant should not get affected by those parameters. That is possible in closed loop control system, because every time you have a sensor, it always senses the output and then ask the controller to minimize that error, and then desired output can be obtained from closed loop control system. So, additional components when compared to open loop system are error detector and a feedback network. These two are the additional components of the closed loop control system. That is why closed loop control systems are costly. Though you get an accurate speed, but it is very costly and complexity also more, because sometimes output may be speed and here controller needs a signal, voltage or current. So, that speed must be sensed by a tachometer, then that should correspondingly convert into an electrical signal, because controller needs an electrical signal to perform its function. That is why the feedback network require a transducer kind of thing, and an error detector, it may be an operational amplifier. That is why costlier systems. So, if you take an air conditioner is expected to maintain the temperature of 16 degrees or 17 degrees depending on the requirement. Irrespective of the outside or atmosphere temperature, it always maintains 16 and 17. So, once the room becomes 16 degrees centigrade, that air conditioner functioning will stop. Once again, if the room temperature rises, that air conditioner will start and see that it maintains the temperature of 16 degrees centigrade. So, this is all theory about open loop control system, closed loop control system, etc. But for an engineer, what is that we require in this particular subject? As I said, this subject mainly, so this control system, there are 6 to 8 units, the total subject is divided. So, our focus in this particular subject is open loop control system and closed loop control systems. Our attention is to analyze the given open loop and closed loop control system. Then we need to have a mathematical model of any control system. So, we need to have a transfer function. So, transfer function or system may be represented in the form of block diagram, or it may be a signal flow graph. A system may be given in any one of the forms, maybe a transfer function or block diagram or signal flow graph. We should be able to analyze the system. So, this is also, it is one of the topics comes under transfer function, block diagram and signal flow graph. Next is time response analysis. A system is excited with certain inputs, and then we can see the response with respect to time is time response analysis. As I mentioned, analysis is nothing but study or know the characteristics or behavior of the given system. So, this I would like to see in time response analysis, any system response with respect to time. So, this is also one of the important topics that needs to be focused along with error constants. The next important term that we need to see is stability. Every one of us aware of the term stability. We say sometimes a person or a system is stable system or unstable system. Stable system means when you give an input, it should produce the bounded output. For a bounded input, if you get a bounded output, we say that system is stable. That is a routine definition of the system. But very important definition, very useful definition of a stability is impulse response of a system must decay as early as possible. Then we say that it is a stable system. You know the meaning of impulse. Impulse is undesirable signal. It is of very high magnitude in very short duration. Such a signal, when it is given to the system, then that impulse response is undesirable. So that must decay as fast as possible. So we say that system is stable. This kind of analysis we will do in this control system, stability analysis, in two domains. One is time domain analysis of stability. In this, we see that RH stability criteria, an algebraic criteria to analyze the given system whether it is stable or not. Next one is root locus. Root locus is a graphical approach of finding the stability of a given system. So this is a time domain analysis of analyzing the stability of a given system. Next domain is frequency domain. Frequency domain is an alternate approach to find the stability, and with the help of Bode plot and Nyquist plot, etc. So with the help of graphical approaches only, we can find the stability, but this is in frequency domain. In time domain analysis, we use a signal mostly called as a step signal, and in frequency domain we use a sinusoidal signal. So this is also one of the major topics in control systems to be covered in detail. Next, design aspect. Once you analyze the given system with the help of various domains, then we need to improve its performance. Suppose, then we may have to go for a controller or compensator. So this is to modify the performance of the given system. That's why this subject I said control system, mostly it's a design by analysis, and analysis is about 80%. So once we know the behavior of the system in certain time domain or frequency domain parameters, then I must use appropriate compensator to improve its performance. Then the last topic in this is state space analysis. Transfer function is a very important mathematical model that probably we use almost in all topics of control system, but state space analysis is something different. Transfer function has got some limitation that it cannot be used to nonlinear systems, time variant systems, whereas state space analysis can overcome that. It can be used for nonlinear systems, time variant systems, etc. So the whole control system is subdivided into this many topics, and we need to see each and every topic in detail.